right now, something from another star system is flying through our solar system. It passed close to Mars in October. It's heading toward Earth. And American telescopes caught the whole thing. This is the story of 3I Atlas, active near Mars, and what it means for all of us watching the skies. On July 1st, 2025, a telescope in Chile picked up a tiny dot moving across the constellation of Hercules. This telescope belongs to a network called ATLAS, which stands for Asteroid Terrestrial Impact Last Alert System. NASA funds this project through its Planetary Defense Coordination Office. The whole point of ATLAS is to scan the night sky looking for anything that might hit Earth someday. But on this particular night, the telescope found something way more interesting than a dangerous asteroid. The object was moving at 137,000 miles per hour. That speed alone told astronomers something important. Anything moving that fast through our solar system is not from our solar system. The sun's gravity can't hold onto something traveling that quickly. Within hours, the Minor Planets Center at the Smithsonian Astrophysical Observatory in Cambridge, Massachusetts, confirmed what everyone suspected. This thing came from somewhere else in the galaxy. Astronomers went back through old images from the same telescope network. They found the object in pictures from June 25th. Then they checked images from the Zwicky Transient Facility at Palomar Observatory in California. Those records showed it going back to June 14. By July 2nd, bigger telescopes started looking at it. The Nordic Optical Telescope in Spain took a peek. The Lowell Discovery Telescope in Arizona pointed its way. The Canada-France-Hawaii Telescope on top of Mauna Kea in Hawaii joined in too. All of them saw the same thing. This object had a fuzzy cloud around it and a faint tail. Scientists call that fuzzy cloud a coma, and a coma means this thing has ice that's turning into gas. Two astronomers from UCLA, David Jewett and Jane Liu, looked at the data and announced that this object was clearly active. That matters because the first interstellar visitor we ever detected behaved completely differently. Back in 2017, astronomers spotted something called Oumuamua. The Hawaiian name means scout. Oumuamua was shaped like a cigar and tumbled silently through our solar system without any tail or coma at all. It looked like a weird rock. And Harvard astronomer Avi Loeb famously suggested it might be alien technology. 2 years later, in 2019, a Belarusian amateur astronomer found another interstellar object called Borisov. That one looked much more like a natural comet with an icy tail streaming behind it. 3I Atlas is the third confirmed interstellar object to visit us. The 3I part of the name tells you that. The I stands for interstellar, and Atlas is the telescope system that found it. So you put those together and you get 3I Atlas. NASA's Jet Propulsion Laboratory in Pasadena, California sent out alerts right away. Every major news network in America started covering the story. CNN ran segments, local PBS stations talked about it, and the reason Americans cared so much is because American technology and American funding made this discovery possible. Atlas represents a $6.5 million investment from NASA. Since 2015, this system has scanned billions of objects in the sky. Lindley Johnson, who serves as NASA's Planetary Defense Officer, held a press conference in July. He explained that the agency funds systems like Atlas for protection against threats, and sometimes those systems deliver unexpected gifts like this one. The path this comet takes through space proves it came from far away. Regular comets in our solar system travel in oval-shaped orbits called ellipses. They loop around the sun and come back again. But 3I Atlas travels in what scientists call a hyperbolic orbit. Think of it like a slingshot curve. The comet swings past our sun once and then shoots back out into deep space forever. Scientists trace the direction this comet came from. It entered our solar system from the direction of the constellation Lyra. It's the same part of the sky where you find the star Vega, about 25 light-years from Earth. A researcher named Matthew Hopkins at the University of Colorado Boulder studied the comet's characteristics and estimated its age. His calculations showed a 68% chance that this object is between 7.6 and 14 billion years old. Our own sun is only 4.6 billion years old. So this comet existed before our entire solar system even formed. Hopkins compared it to finding a fossil from a completely different era of the universe. Now, here's where the story gets really exciting. On October 3, 2025, this ancient traveler from another star system flew past Mars. The distance at closest approach measured 18.6 million miles. That might sound far, but in space terms, it's practically a handshake. For comparison, that's about 78 times the distance between Earth and the Moon. This timing worked out perfectly for NASA because the agency has multiple spacecraft orbiting Mars right now. The Mars Reconnaissance Orbiter, which launched from Cape Canaveral, Florida back in 2005, carries a powerful camera called HiRISE. This camera can spot objects as small as a dinner table from 150 miles up. On October 2nd and 3rd, that camera captured the sharpest images of 3I Atlas that anyone has ever taken. The images showed a bright, somewhat blurry blob with a reddish coma around it. Scientists at JPL analyzed those pictures and estimated the comet's core, which they call the nucleus, measures somewhere between 1,400 feet and 3.5 miles across. That makes it bigger than Borisov, but smaller than many comets that formed in our own solar system. Another NASA spacecraft called MAVEN also got involved. MAVEN stands for Mars Atmosphere and Volatile Evolution. It launched in 2013 to study why Mars lost most of its atmosphere over billions of years. On October 9th, MAVEN's ultraviolet spectrograph, which is a tool that breaks light into its component parts, detected carbon monoxide and water vapor in the comet's coma. Those chemicals show up when ice turns directly into gas, a process called sublimation. Bruce Jakoski from the University of Colorado serves as the principal investigator for MAVEN. He described the comet as exhaling ancient breaths. Those breaths contain material that has been frozen for billions of years, possibly since before our sun existed. Even the Perseverance rover on the surface of Mars looked up at the comet. Perseverance has been exploring Jezero crater since 2021. On October 3rd, the rover tilted its camera toward the sky. At 170 million miles away, the comet appeared as just a faint streak. But every bit of data helps. Scientists fed the rover's observations into computer models that track the comet's exact path, and those observations improved the accuracy of those models by a factor of 10. European spacecraft contributed too. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter both captured images from October 1st through October 7th. Their viewing angle let them see the comet about 10 times closer than any telescope on Earth could. Meanwhile, NASA's Psyche mission also grabbed some pictures. Psyche is a spacecraft traveling toward a metal asteroid it will reach in 2029. On September 8th and 9th, while still 33 million miles from the comet, Psyche used its multispectral imager to track the reflected sunlight bouncing off 3I Atlas. Jim Bell at JPL noted that even at that extreme distance, the spacecraft pinpointed the comet's position precisely. The scientific results from this Mars flyby keep getting more interesting. The European Space Agency Trace Gas Orbiter confirmed that 3I Atlas poses no collision risk to Mars or Earth. MAVEN's data suggested that solar wind, which is the constant stream of particles flowing from the sun, is stripping away parts of the comet's coma. Some of those stripped materials might actually fall into the thin Martian atmosphere. Lori Leshin, who heads NASA's Planetary Science Division, called this a natural experiment in how interstellar material gets delivered to planets. So what exactly is happening on this comet to make it so active? As 3I Atlas got closer to the sun, it warmed up. The ices on its surface started sublimating, turning from solid straight into gas without ever becoming a liquid. That process creates the coma and the tails that make comets so beautiful. The Hubble Space Telescope, operated by NASA's Goddard Space Flight Center in Maryland, captured images showing a coma about 40,000 kilometers across. Inside that coma, Hubble detected methanol and hydrogen cyanide. Both of those chemicals are what scientists call prebiotic. They're the kind of molecules that can eventually lead to the building blocks of life. By December 12th, new images from the Gemini North Telescope in Hawaii showed the comet getting greener and brighter. The coma had swelled up to 100,000 kilometers across. The green color comes from something unusual. Spectral analysis reveals nickel ions in the coma. That's rare for modern comets. But it makes sense for something this old, formed in a region of space with different chemistry than our local neighborhood. The comet's tails are spectacular. One tail glows blue and streams in the same direction as the solar wind. Another tail glows green and flows in the opposite direction. The second one is called an anti-tail, and the nickel content makes it glow that unusual green color. A photographer named Sebastian Voltmer captured an image on December 1st that spread all over astronomy forums. He called it unlike any natural comet he'd ever seen. Two jets of gas shoot from the comet's surface. These jets stretch up to 3 million kilometers long. One of them points in an unexpected direction, toward the sun instead of away from it. That challenges the simple models scientists use to predict how comets behave. Usually gas just shoots away from the warm side. This asymmetric jetting suggests something complex is happening. Maybe uneven ice deposits on the surface or unusual rotation patterns. A Japanese and European mission called X-RISM detected an X-ray halo around the comet on December 3rd. This halo extended 400,000 kilometers and showed unexpected spikes in carbon, nitrogen, and oxygen at certain energy levels. Scientists think the solar wind is causing something called charge exchange within the comet's atmosphere, but the exact details remain a puzzle. The James Webb Space Telescope, which NASA launched from French Guiana in 2021, observed 3I Atlas on August 6th. Webb's near-spec instrument found that the coma contains mostly carbon dioxide. The ratio of carbon dioxide to water in this comet's atmosphere is 10 times higher than any typical comet from our solar system. John Mather, the deputy project scientist for Webb at Goddard, said this makes the comet hypervolatile, probably because it formed in a much colder stellar neighborhood than ours. All these NASA missions together paint an incredible picture. Hubble locked down the nucleus size back in July when the comet was still 277 million miles away. Webb cracked open the chemical composition. A mission called TESS, which normally hunts for planets around other stars, tracked brightness changes as the comet rotated. The Swift satellite called Early Flares, the Parker Solar Probe, NASA's brave spacecraft that flies incredibly close to the sun, sampled how the solar wind interacted with the comet in September. Mars missions contributed the most detailed data. The Mars Reconnaissance Orbiter and MAVEN both fall under management by JPL in Pasadena. But something went wrong on December 6th. MAVEN stopped communicating after emerging from behind Mars. Its last transmission included ultraviolet images of the comet's coma. NASA teams in Laurel, Maryland posted that they are investigating a power problem, which happens sometimes on spacecraft after 10 years of operation. The timing bothered some people since the Earth flyby was only days away, but engineers point to routine issues rather than anything mysterious. So how can you see this comet yourself? Right now, 3I Atlas has moved past its closest approach to the Sun, which happened on October 29th and 30th. The comet reached perihelion at 1.4 astronomical units from the Sun. 1 astronomical unit equals the distance from Earth to Sun, so 1.4 AU puts the comet's closest solar approach just inside the orbit of Mars. Now, the comet's heading outward and getting closer to Earth. On December 19th, it'll reach its nearest point to us at 1 AU, which works out to about 170 million miles. That's plenty safe. No danger at all. And the good news for stargazers is that December 19th is also a new moon, so the sky will be nice and dark. The comet currently glows at around magnitude 8 or 9. It's too dim for the naked eye, but bright enough for binoculars if you find a dark location away from city lights. By December 13th, the comet sits about 90 degrees away from the Sun in the constellation Pisces. It rises around midnight and climbs higher as the night goes on. If you live on the East Coast, look east after 11 p.m. The comet will be near the Great Square of Pegasus. Miami's humidity can make viewing tough, so consider driving out to Everglades National Park. In the Midwest, you get clearer skies earlier. Chicago's Adler Planetarium is hosting viewing events. If you can get to Big Bend in Texas, the dark skies rival anywhere in the country. On the West Coast, the comet rises before midnight. Seattle has light pollution problems, so Mount Rainier makes a better choice. Los Angeles has the Griffith Observatory running live streams. Arizona offers great options at Lowell Observatory. The best tool for finding it is a smartphone app. Stellarium is free for both iPhone and Android. Sky Safari works well too. Point your phone at the sky and the app shows you exactly where to look. A pair of 10 by 50 binoculars will reveal the green coma nicely once you find the right spot. Dress warm. December nights get cold across most of the country. In the Rockies, temperatures drop below freezing. The American Astronomical Society is organizing events, and NASA has a citizen science program called Globe Observer where you can contribute your own observations. By January 22, 2026, The comet will have dimmed to magnitude 12. You'll need a telescope to see it at that point. By March, it will pass Jupiter's orbit on its way out of our solar system forever. Its velocity will peak at about 221,000 kilometers per hour as it exits. The scientific legacy of 3I Atlas will last much longer than the comet's visit. The data collected by NASA missions advances our understanding of how comets work, improves planetary defense systems, and opens new questions in astrobiology. Chemicals detected in the coma, things like methanol and hydrogen cyanide, relate directly to how life might arise on planets. Researchers at SETI in Mountain View, California are already studying whether these compounds could support alternative biochemistries. The whole experience also refines our models of the Oort cloud, which is the distant shell of icy objects surrounding our solar system. Some estimates now suggest interstellar objects passing through our neighborhood might outnumber local objects by 10 to 1. Future missions like ESA's Comet Interceptor, planned for 2029, aim to visit such travelers up close.